So in this video, I'm going to go over the 3.2, 3.3 homework packet. So these first 6 problems are in exercise 3.2 of your textbook. So that's the Cengage online textbook. And for these 6 problems, you're only going to complete part A. Okay? So I did not write down my functions, but I have indicated when they are odd or even. So this little notation you may use if you like. This is telling me that the degree is odd and the leading coefficient is positive. When that is the case, this is how it looks. Now, you cannot just write this down for your end behavior. This is just think of it as your little cheat sheet. You have to write this out. So if you're on the left side of your graph, and this is, as I said, an odd degree, as x goes to negative infinity, which always happens on the left side of your graph, where is y going? Y is also going to negative infinity. On the right-hand side, as x goes to positive infinity, that's where y is going as well. Okay, question 10, if you look at it, I'm going to see it's an even function with a negative leading coefficient. For that reason, this is my little cheat sheet, and I can say, looking at this first downward arrow, as x goes to negative infinity, y is going to negative infinity. This other arrow, as x goes to infinity, y is still going to negative infinity. Notice that in even functions, y's are heading in the same direction, whereas in odd functions, y is heading in opposite directions. Okay, here's another odd function. This time the leading coefficient is negative. So as x goes to negative infinity, y is going to infinity. As x goes to positive infinity, y is going to negative infinity. They're going opposite. Okay, 12 is an even function with a positive leading coefficient. So as x goes to negative infinity over here, y is going to go to positive infinity, and y is going to go to positive infinity again when x goes to infinity, which happens to the right. Okay, here, question 13 is an even function with a positive leading coefficient. So therefore, 12 and 13 have the same results. As far as 14 goes, 14 is, let's see, it's an odd degree, and it is a negative leading coefficient. So therefore, 11 and 14 follow the same pattern. No, excuse me. 11, let me think about this. I'll look at this again. So let's keep going on this. So I'm going to go to the next page. Okay, so I just checked my textbook. So 11 and 14 should have the same answer. So just make that correction if that's what you need to do. Okay, so then for the following problems, here's 3. These are the different things you have to do. Is the degree of the function even or odd? Let me just make this a little bit smaller so we can see a couple of problems at once. List the zeros. Okay, so this is what I'm having. I can see the arms are up, up. I know the function's even. Down, up, that would be odd. Okay, in terms of your zeros, I have negative 3 with a multiplicity of 1. I have negative 1 with an even multiplicity, and I have 3 with a multiplicity of 1. Okay, E is for even. The degree of the function, the minimum possible, I have 1, 2, 3, and one more is 4. Okay, here's my polynomial in factored form. Here is my pass-through single root expressed as a factor, x plus 3. Here is my double root right here, is expressed as a factor with a multiplicity of 2. And here's the other single root. In terms of domain, all the polynomials will have all real numbers for their domain. And the range, you start low. It goes from negative 1 inclusive all the way to infinity. Okay, the second one has to be odd because the arms go in different directions. What do I have in terms of my roots? Negative 3, multiplicity of 1. -1 multiplicity is even, and 2 multiplicity is also even. So in terms of the minimum degree, 1, 2, 3, 4, 5. Okay, here are your factors. Here's the multiplicity. The domain for both, well, the domain and range for both, for these functions that are odd is all real numbers. And you can express all real numbers this way, or you can say negative infinity to positive infinity. Okay, so let's see if we can go down a little bit more. Before I go down, let me just come back to this problem number 2 because I skipped it erroneously. So you need to state whether the graph is a polynomial function, and if it is, state the least possible degree. So this is polynomial, it's smooth. I can draw it without picking up my pencil, and there's no sharp edges. So this has a possible degree of 2. This is not a polynomial. This is not a polynomial because of these sharp points. This is a polynomial. I have a degree of 1, 2, 3, 4, 5, 6. This is a polynomial. I have a degree of 1, 2, 3 at a minimum. Here is a step function. That is not a polynomial. Okay, so now we're ready to go on to the next page. My apologies. So we've done the first 2. Let me just drag this down and do the next 2. Okay, so 3 and 4, they are both even, but notice one is up, and one is down. When it's down, you have to provide the negative as a leading coefficient. Okay, when it's up, it's a positive leading coefficient. Okay, so you should be able to look at these, single root, single root, single root, single root. That gives me 4 factors with a negative leading coefficient. The domain is all real numbers, and the range goes from negative infinity because they're going down forever and ever, and then you kind of go up, and this is the highest it can go, and I said that's about 25. And remember, that's going to be inclusive. So here's even, here's single root, double root, single root, double root. That's why I have the power of 2 for these 2 factors. And in terms of domain, all real numbers for this function, and for all polynomial functions, and for the range, here's my lowest. I said it's about -50, and it goes forever and ever up. Okay, and I think that's it for this page. Let me just verify that. Yes, we're good. Okay, so here's a couple more, 2 more, same idea. I see the arms of the function are going different directions, so I know it's odd. Here is a double root, thus I have a double here. Here is a single root. Now, because the arms are up, down, what's going to happen is I have to put a negative in front because I have a negative leading coefficient. For odd functions, domain and range are the same, all real numbers, or you can write negative infinity to positive infinity, non-inclusive. Okay, here's number 6. Here's a single root, double root, single, single. So here they all are. Again, the arms are up and down. That makes the leading coefficient negative, and the domain and range are exactly like they were for number 5. All right, that brings us to 4, and you can see that they gave it to you in factored form. So there's 4 problems. So factored form, the end behavior is telling me that I have 1, 2, 3, 4, 5, 6. It's degree 6. The leading coefficient is positive, therefore the arms will be up. That will give me this behavior. Okay, y is going to infinity both directions. This next one, I have a leading coefficient that's negative. This is my arms. So this is how I describe my end behavior. Again, if you write just this, game over, no points. You've got to write this out. Okay, now let's talk about the y-intercept for both of these. To get the y-intercept, you're going to set the x's to 0. When you set the x to 0 in this first factor, you get a -3. When you set the x to 0 here, you get a 1, but you get 3 of them. When you set the x to 0 here, you get a -2. Okay, what do you multiply to get the y-intercept? You multiply -3 times 1 times 1 times 1 times -2 times -2. And that gives me a -12. Same idea here. Plug in the 0 here, here, and here. That's going to be +2 times +2, -4 times +1. Now this has an impact. That's what keeps my y-intercept negative. All right, this next one, C, 2, 3, 4, 5. The degree is 5. The end behavior, because this is negative, it's going up and down because it's odd. So then here is my explanation about the end behavior. Okay, the next one, 1, 2, 3, 4, 5. The degree is 5. This is going down and up. And so in this situation, here's what I'm going to write. It is the opposite of what I have here. So as x goes to -infinity, y goes to -infinity. As x goes to +infinity, y goes to +infinity. Make sure you can get these y-intercepts. Remember, you get them by plugging in a 0 here, 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 and here. So let's do this one so that we're really on top of things here. This, plugging in a 0, gives you a +1, not a -1. -1 is the root, not the y-intercept. So this is going to be 1 times 1 times -2 times -3 times +4, and then make the whole thing negative because the leading coefficient is negative. So that's how I'm getting -24. Okay, here, 1 times -2 times -2 times -2 times a -3. That's a +24. Okay, so let's go on. Okay, so what we're going to do, this is back again in 3.2 of your textbook. So your job is to determine the degree, define the end behavior, identify the x and y intercepts, be sure to label these, determine the multiplicity of each 0, obtain additional points as needed. So in class I talked about, like, you know that this is going to churn back down, but how high does this get right here for 17? You could plug in extra numbers here, which is what I did to give me an idea of how high it's going. We're not going to require that of you, but it is a way to make your graph more accurate. So I'm not going to go through all these. I'm just going to slowly go down them. Okay, notice that I found the vertex here, and your vertex is always -b/2a. So I found that to kind of figure out what's happening with my quadratic. So, but I'm not going to require that of you. What you have to know is the degree, the end behavior, the factors, the multiplicity, the y-intercept, and the end behavior written this way. Okay, so I'm just going to go slowly down them so that you can see what's going on. Okay, so here's some more. Here's some more. Okay, the last two, I don't think I filled it all in, so let's just talk about that. What I did was I first factored it, and then I could have gone through all those specs, and I really should have. So let's talk about them. The end behavior is as x goes to -infinity, y goes to -infinity. As x goes to +infinity, y goes to +infinity. My y-intercept is going to be what? Well, if you plug in a 0 here, here, and here, you get 0 times -6, which is still 0. So that tells me if I have a factor of 0, look what happens every single time to my y-intercept. It becomes 0. Okay, so end behavior, we talked about end behavior here. This is a factor form, gives me a degree of 4, right? 2, 3, 4. Double root here, single, single, and behavior as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. So the key thing is, before you analyze this, factor it first. Okay, so let's go down a little bit more. Okay, here's matching. So we talked about the easiest way to do this matching. You could kind of go through it and say, oh, let me figure all this out. This is so fun. Or you can figure out what is your degree. This is 2, 3, 4. That makes it even, and the negative coefficient is missing, so therefore I know the arms are up, up. So go ahead and figure out, do I have a double root at -1? I do. Do I have a single root at -3? I do. A single root at +2? I do. This matches that. Okay, go to the next one. This is 2, 3, 4. This is also going to be up, up. So let's see what I have. I have a double root at -3. So come down a little bit and see where you have a double root at -3. Oh, bingo, right here. And look, it's up, up. So I also have a single root at -1 and a single root at 2. So D goes with D here. Okay, look at E. Let me just slide this up just a hair. This is 1, 2, 3, 4, 5. Okay, that's going to be odd because there is no negative here. It's going to go down, up. So here's a candidate, but I don't have a triple root at -2, so that's not going to be it. So let's slide down, and you can see how E does have that triple root. So you can match up the rest of it, and then you're good to go. So here, I'm doing this strategically. Okay, so you can see where the rest of them are. See if you can follow that reasoning. Those are all my answers. First, find out the degree. Find out if your leading coefficient is positive or negative. And then once you do that, look at your graph. Look for characteristic roots. Are there doubles? Are there odd ones? Are there single roots? What you have, match it up. Okay, so this is all synthetic division. So I want the quotient and I want the remainder over the divisor. So remember here, do not be fooled. You do not have a constant. You've got to put in a 0. Here you have 3, 2, 1 blast off. You've got everything you need. Notice there are no zeros. Neither of these are roots. Okay, x plus 1 is not a factor. X plus 2 is not a factor. I know that for a fact because my remainders are not 0. So just check those, make sure that that makes sense to you. Here we have 2 more problems. I don't have a power of 4, therefore I have a 0 there. I don't have a quadratic. I don't have a linear. You've got to have these 3 zeros in the appropriate places to get this correct. Because I have a remainder, I know that this is not, x minus 1 is not a factor of this polynomial. Here's my quotient. Don't forget that if you have a quintic raised to the power of 5, your answer, your quotient will be a quartic. It always goes down by 1 power. This is a cubic. Be very careful. I don't have a quadratic term. I don't have a linear term. I have to have these 2 zeros here, otherwise it's not going to be a happy day. Notice that my remainder is 0. That tells me that x minus 3 is a factor of the original polynomial. So that is a key piece. Okay, so that concludes this. I hope you found this useful.